Hi guys, welcome to another Learning Electronics Repair video. This video is sponsored by PCBWay, who kindly donated the PCBs for a variety of projects which we are building. We have more to build. So this is the RF signal generator, 10 kHz to 255 MHz. And I was playing around with this, or say playing around, I was trying to build this in the previous video. And I had some problems, and the main one was at the Arduino Nano that I ordered. I ordered the version with the Atmel 168 chip and not the 328 chip. It wasn't specified in the parts lists, and I just, did what you do, and grabbed the cheapest one. So when I came to compile the code, it wouldn't work. Wasn't enough room. So I met up last week with a guy who has a YouTube channel on here, Detlef Amend. He was on holiday over in Gran Canaria and said, hey, shall we meet for some beers? And as well as meeting for some beers, in exchange he gave me a couple of Arduino Nanos, the correct ones. So cheers, Detlef, for that. Detlef actually builds some little electronics projects. I'll link his channel on here. I've mentioned him before. And he's a really nice guy, yeah, and thank you very much for the bits that you gave to me. So I can carry on with this project, yeah. I've got to fit the little RF signal generator, which should go here, and I, in error, soldered on these connectors that I didn't need to solder on. So it doesn't actually fit, it hits the Arduino. But one of the subscribers, at least one, suggested that what I should do is fit into here like some riser pins. I'm going to take some from a socket from an IC socket. I should be able to raise this up a little bit so that I can actually plug this in a little bit higher up and it will fit. Other than that, I have to put a push button switch here for the band. And then this TX pin, this is actually a switch. I looked up on the schematic, and it's basically a switch that adds effectively the IF frequency, the intermediate frequency, to the RF frequency that you're generating. I think the idea is that if you want to tune your radio to a channel on 1 MHz, you can set this to 1 MHz, and this will add the appropriate IF or intermediate frequency signal. I was talking about this on a video we did on the radio repair, so I'll link that one as well if you want to know a little bit about IF frequencies. But we can have a play with that when we get it working, yeah. So I'll find something to extend this up with. We'll do a bit more soldering, then let's power this up and see if it actually works now. What was suggested to me, it is a good idea. This is a 14-pin IC socket. The little clock generator board has 7 pins. So the idea was to effectively put this into the socket, which will raise it up a bit higher, yeah. Solder the socket into the board, and then I have enough room to clear the Arduino with the clock generator. And if that doesn't work, I can actually stack the other half on here and make it a little bit higher. So let's give this a go. We'll try first just chopping it in half, which shouldn't be too difficult, to be honest. Okay. I can now solder this into the board, and then we'll see if we've got enough room to fit our clock generator. So this just goes on here. A bit of solder. I'll just bend a couple of pins over so it doesn't fall out, and we'll attach this on here. Well, give it a go then. This is some new solder. I ran out of my old one. Somebody said that this cheap solder, which is it's this one, 6040 LED tin solder. It's already solder, and somebody commented said it would be rubbish. So it feels a little bit less flexible than the other leaded solder I was using. But let's see how good it is. I mean, it solders. Seems to work just fine to me, but time will tell, I guess, when I try and mix it with, for examle, lead-free solder, when I'm trying to unsolder things or reballing chips. But yeah, it went on there. Let's see then if this idea is going to work. So the idea was that this would raise up the thing. A very simple idea, but it appears to be a very effective idea because it now fits. Okay, so we have that there. We'll just solder on the switch. This connector is for a signal meter, but I don't have a signal meter at the moment. And this is something else somebody talked about this project. It's marked as an LM7808, which is an 8-volt regulator. I don't have one, certainly not a surface mount. I have ordered some. I ordered a kit like 7805, 06, 08, 9, 12 and 15, so there's like 5 of each, but they haven't arrived just yet. So what I think I'll do for now is either attach onto here effectively a through-hole one, which I should be able to do, or maybe I will just tag my power supply on here and put 5 volts in. Yeah, we'll do one or the other. So let's just put our switches on. Okay, so I've soldered the switches on for now, and I can move them all if I put this into some sort of enclosure, which I will. I'll show you my plans for that a little bit later in this video. But for now, we can just attach the switches. I don't have a suitable regulator put here. I had looked to see if I could fit a normal through-hole one. I probably could, but it was a bit fiddly. So for now, I'll just attach some bits of wire and put my bench power supply onto 5 volts. And we'll power the project up and we'll see if it works. As well as PCBs, by the way. PCBWay sent me some nice little stickers. So as soon as they gave them to me, I thought, wow, yeah. I'll do them a favour, so there you go. PCBWay for all your PCB needs, yeah? Just a bit of wire off some old network cables and things. I often strip old bits of cable and stuff, very useful. This shouldn't draw a lot of current, so I doubt the voltage drop down this bit of wire is going to be a problem. But I think we can measure that as well, yeah? And we put this on the bench power supply also, we'll know what sort of current this is actually drawing. So let's solder this on and then we can connect this up to our power supply and see if it actually runs. Not sure which way round to put it. Let's put the blue to negative. Why not? And then we have the blue and white as positive. Unconventional, yeah, well, that's what we'll do. So soldering iron's on asleep. Okay, soldering iron. I have to say, I do think the solder's actually as good somehow as the mechanics one had a 500 gram reel of it. It's just, I mean, solder's okay. Not quite sure what it is about it, but something doesn't seem quite as good. I got some other as well. While we're at it, let's have a look at them. This one's 0.6 mil, but they both say they're 0.6. Yeah, they probably are the same thickness, but this one feels a bit more like normal solder, if you know what I mean. Let's have a... Yeah, they claim to be the same stuff, and then I have this that somebody gave me. Whole roll near enough. Wuppertal. I'm not sure if I can tell any difference between the three. I'm going to have to play around with these solders. We'll do something, yeah. We'll do something. Is there any difference between this cheap stuff from AliExpress and this, which I believe is quite decent stuff, yeah, but more expensive? We'll come on to that. Nothing but a bit of variety on this video, guys. Okay, so let's just tag our wires on. See if I need any more solder to do it. So these 780 whatever positive voltage regulators, the last 2 digits is basically the voltage, the regulated output voltage. Probably want a bit more solder. Yes, I do. Now let's have a go. Well, actually I wanted to put the blue one on here. Okay, that's got a grip. No, that's interesting. Is this a solder? Or is this just me? Try it again. Okay. No. Interesting. Some of this on it. Solid. Oh, that's interesting. That's it. The basic one is kind of like, it's got the stuff mixed together, the two solders. I don't know if that's responsible. I'm definitely going to have to play around with these to see what is what. Any suggestions on how to test them all, other than just soldering things and see if it works? Yeah, let me know. Right, so we have our power. So effectively this pin is always in. You can see it's going to where the power socket comes in, and this pin is out, and we're going to put 5 volts into this, not 8 volts, and let's see what it does. Let's use the little power supply, the 10 amp 30 volt I reviewed last week. You can just see, by the way, that's my, or one of my other two. So I have down there the very large one, which is dual output, 30 volts, 5 amp 30 volt, 10 amp. You can see it's much smaller. Obviously it's much shallower as well. It's a lot less depth to it. So let's try this. So I'll just, before I connect the wires, I'll just switch it on and we'll set it to 5 volts. Now, some people agree with me about this. It's an inexpensive power supply. It's cheap, yeah. It's cheap. It's one of the cheaper ones available. And I think it's a useful device. I think most people tended to agree with me. At least one person said it was utter garbage, was his opinion on it. And yeah, you're all entitled to your opinions. I think for an inexpensive power supply, it's quite good. So let's try it. Let's use it a bit. So we'll use this in some upcoming videos, and then let's figure out, is it utter garbage, which I don't believe is the case. So I can connect my little project now, and it's drawing 40 milliamps. It doesn't draw much power, and something's happening. Oh, it has a built-in signal meter on it. Okay, but what's pressing the button do? Oh, I see. Pressing the button goes to the next digit. 8. This is your megahertz, I'm guessing. So let's set it to, well, oh, that's nice. It automatically went to 1 by itself. That's rather nice. What's this do? 10, 11. Oh, this is going to like some preset frequency bands by the looks of it. I believe, I'm not sure if you can set these yourself. It's just like effectively the band WFM 100 megahertz, 130 air, 140 2 meter band, 144, 1 meter band, 220, gen, 100, medium wave. Oh, I see. That's quite nice. 160 meter. 80 meter. Oh, I like this. Yeah, look at that. It's going to like various amateur radio bands basically. And we're on 10 megahertz. What's this switch do? This is something to do with the IF frequency. I think we switch it this way. Well, it's changed the display. It says TX. RX. I've got a feeling that changes the frequency. I guess this is your standing wave ratio, which is bad because I don't have any antenna attached to it. I hope I don't damage it, but this thing is very inexpensive. So let's go again, see if we can just set it to 1 megahertz. Yeah, we can turn it down, we can push the button, we can go in 10s, and we can go in 1s, and it goes to 1. Okay, so let's connect our oscilloscope and let's see what we have coming out of this. And that's probably a good idea. Have we got any RF coming out of it? Let's have a look. I'll just take this off here as well. It might look a bit clearer without the little plastic cover on. So we can see it's set to 1 megahertz. If I just connect my scope probe, so I'm sure, so I'll just check where the tracks go, that this is where you should attach your antenna or your load. So if we go onto here, we can see it is oscillating, and if I probably make that window a little bit bigger, or even better, move my camera a little bit closer to it. Yeah, I'm sure you can see there. So it's saying frequency is 1 megahertz, period 1 microsecond. Okay, so it's obviously giving us that. And I've just gone over to the voltage reading, and the voltage peak to peak is about 6 volts, near enough. Let's just alter the frequency, so we'll go up to 2 megahertz. Well, it's definitely double the frequency. So if we go again, yeah, we're up at 4 megahertz now. Just alter the scale on here a little bit. Oh, that's interesting. Now it looks like a sine wave, whereas before at the lower frequency, it looks more, well, it looks like a peculiar shaped wave. I don't know if that's something to do with my scope probe, or something to do with the generator, or something to do with not having a suitable load on it, maybe. Can we go down further? Oh yeah, we can go singly. Let's take it down to its low frequency. So it should go down to 10. Oh, but it's gone high. So I just need to figure out how to use the controls. It's now gone to the maximum frequency, which is above the range of my scope. Yeah, my scope can't handle that. Keep pressing the button. Yeah, so pressing the button effectively goes into the range. We go again. We're in megahertz now. We can probably go in. No. Oh, I see. So megahertz at a time is the fastest we can go. Does it wrap around? Let's have a look. So 225 is the maximum. No, it doesn't wrap around. So there's a bit of knob turning going on here to get to the. Oh, unless we press this band gen. Oh, yeah, this will go into this one. That effectively chooses different bands. That's a quick way to move around. So you can see on the scope, this is definitely working. Definitely working. But at the lower frequency, it gives that strange waveform. Somebody, I'm sure, can tell me why, because I don't totally believe what I see on the scope is what's really happening. I'm interested to see how I can get this down to the low frequencies. Let me have a look. Okay, so by selecting Gen, by pressing this button, I'm now effectively on the low frequency. So this is 10 kilohertz. You see it's giving a square wave. And I can just increase the frequency 20. Let's go to 100 kilohertz. Yeah. And at these low frequencies, you get basically square waves, and it seems to go to like a sine wave as we increase the frequency. On the setting Gen, does it just give us a linear range, if you like? I'll just have to change the scale again. You can see what it's outputting. Yeah, it looks like on this you can effectively just keep increasing the frequency. So at what point does it turn into a sine wave? Well, you can see. Just keep going up. It's getting a bit more sine-ish. And there at about 3.74 megahertz, it effectively turns to a sine wave. Some of you guys know a bit more about RF. I'm sure we can comment on that. But I have to say, this appears to be working. Yeah, it actually seems to work. Now this is basically working, there's a few things I want to do with this. Obviously this is going to get built into its own case. But I want to add a few things to this. This will be useful, I think, for myself when I'm working on radio microphones. Not the UHF ones, it won't go that high. But there's a lot of VHF ones around here. And I'm pretty sure this will help me to figure out if it's the transmitter, the microphone or the receiver that is or isn't working properly. But I would like to add a few other things. So I'd like to add AM modulation, so effectively I can use this like a little AM transmitter to test radios. Let's do FM as well, just for the fun of it, because it's interesting. I've never done this sort of RF thing before. I'm quite a newbie to RF repair. I used to fix CB radios back in the early 80s, but I didn't really know what I was doing too much. I could fix some of them, yeah. I'm sure now I could fix more of them. I'd also like to make this into a signal generator and frequency counter, and I've got an idea how to do that as well, which will involve PCBWay. But I think today we can probably add an AM modulator to this. A little while ago, a few months back, I was looking around and I came across a channel on YouTube, which I'm going to show you now. So the owner of this channel is Don. Had a quick chat with him. He's a really nice guy. I asked him if I could use one of his circuits on my channel, and he said by all means, and please let me know so you can see what I've done with it. So this is Don's channel, and this is what we're hopefully going to add today. Don has a specialist electronics repair channel, as you can see. Restore old radios. Right now he's just short of, it looks like he needs just 10 more subscribers to get him to the 10k. So maybe, hey, if one or two guys, I say one or two, if a dozen or so of you guys would like to help, I'm sure we can get him there. And I had a look through his videos and I found a particular one that I was interested in, so I asked Don if I could use it. So this is Don's amplitude modulator circuit. It's very simple. You can see me here chatting with him, and this is a very, very simple circuit. So if we can just go into the video, I'll actually show you where it is. Okay, so this is the actual circuit, yeah, of the amplitude modulator. You see, it's very simple. It's passive, doesn't require any power. It's just what, 3 capacitors, a couple of diodes, a variable resistor, and an inductor. I mean, that is it, yeah. So I've ordered the diodes. These are germanium diodes. I had to order the right sort. I didn't have any germanium diodes, and some of the RF chokes, which I'll show you in a minute which type they are. So I ought to order those. All the rest of the bits I could find lying around. So we should, with a bit of luck, be able to connect this to the output of our signal generator, feed an audio signal, and effectively get a little radio transmitter out of it. Silly enough to test maybe a radio sitting on the bench. So let's give it a go and let's see if we can get it to work. This is the actual project built on a breadboard. I'm going to put it together on a bit of Vero board because we know it does work, thanks to Don. This is the type of inductor. I ordered a pack of 20 different values or something from AliExpress for, I don't know, €1 or 2. It wasn't very much. And the diodes I had to order again, they weren't very much. So let's put this together on a bit of Vero board and let's see if it works as we expect it to. This should be quite easy to build. So we have a bit of Vero board, the 1N34A diodes, a couple of 100 nanofarad. I hope these are the right type. I'm not an expert on RF stuff, so if I've used the wrong type of capacitor for some reason, although it's the right value, let me know. Let me know why it's wrong. Yeah, I found a 10k part of salvaged one. I have a 100 microfarad. It didn't specify any voltage. It's a 25 volt. And then I bought a little kit of these from AliExpress, so it didn't cost me very much. These are lots of these bead type inductors, or what type they're called, RF chokes. He says use an 820 or a 1000. What do we have? We have 680s. We have some 1000s, so we'll use one of the 1000s. That's the one of the two values that Don suggested, so we use that. And this should be really quite easy to build because basically we just have, like on one track of the Vero board, we have a capacitor, a diode, an inductor and a capacitor all in series. So we just need to cut the tracks in between. If we just put a whole line of those in and out, this can straddle the variable resistor across 2 tracks. Diode comes down across the same 2, and then we just got RF, AF and ground. I mean, that's it, yeah. I've put that together on a little bit of Vero board then according to that schematic. A little bit messy, but hopefully it'll work. Again, if we can get this working, we can make a little PCB for this, get PCBWay to make them up. That's nice. So this is the audio input coming in, goes via the 100 microfarads to the wiper of the variable resistor. You can see it's just there, yeah, so that's that. Coming in, your variable resistor this end, basically just ground, goes this little link here to the bottom end of this diode, that's that, and then this is a ground pin. Then basically you will connect them in your RF in here, through the first capacitor I've cut the track, then through the diode where I've cut the track, and then it goes to the little inductor bead where I haven't cut the track. I better just do it, so I'm glad I checked. And after the inductor bead it goes to the capacitor, and the other side of the capacitor there, that's the other pin. So we just need to cut that other track. Always worth making a final check on these things. And now let's connect it to our little signal generator. Let's see if we can modulate the output with some audio. I'll just solder a couple of short pieces of wire at the moment. And if we put this together, we can use some proper connectors and little bits of coax, but I'm sure for the point of view of testing this will do. So that is the RF signal coming in, and I think we need to attach our ground, yeah, over here somewhere. That should do. Probably this one will fall off, so I tagged it on the back. So we can just move it a little bit away from there. And hopefully it won't fall off. Yeah, I think we've got it. Okay, so let's power this up again. Let's stick some audio in. Let's see if we actually get an RF modulated output on the pin here. And there you go, guys. I'm feeding some music into it, and you can see it's modulating, yeah. Quite nicely. So that is working. I've just crashed my camera. It doesn't seem to like the RF around here with this thing running, but it's a bit dodgy, this camera, anyway. Okay, I have the camera working again. In fact, you can see I now actually have the scope probe just lying near to this generator. It's obviously working. Look, I can change the frequency on here, yeah. So this is actually transmitting quite nicely. I mean, I'm not sure what power it's putting out, but there's some power there. And that's without an antenna on it. So I have to say that this definitely works, and I hope there's no interference on the microphone, because it was upsetting my camera, and it was also sometimes buzzing on my PC speakers as well. But yeah, I think we have to call that, guys, something of a success. Thanks once again to Don at Restore Old Radios for letting me kindly use his project, his circuit design. We can see it definitely works, so we can build that in to the box with our generator. I'm very interested in also putting together an FM modulator. If for no other reason, I think it can be quite a lot of fun. So, hey Don, if you're watching this, maybe you can suggest, or some of you other guys in here can put some suggestions towards that one. Hopefully something simple that we can put together again, like I did with that little AM modulator. Otherwise, we'll get some PCBs made up for that one. PCBWay have lots of shared projects on their site. I'll just show you. In here, these are projects that people have basically designed or uploaded themselves, and if you build any of these projects, then the designer gets a 10% commission from the sale of the PCBs, and you can too. So if you want to upload any projects of your own on here, if they're popular, you can make yourself some money. It's a nice way to get some money from your own projects without having to order your own PCBs and invest money in it hoping you're going to sell them. So on here you just put your projects on, and then you can make some money from that. I've had a look at some of them, and this is the one that caught my eye to go along with the RF signal generator. So you can see the project here. I'll show you the PCBs in a minute. It's fairly simple. It has an Atmel processor on there. I need to order some bits, so I'll be able to put this one together next month. It was originally uploaded by this guy who has a YouTube channel, so if we have a quick look, this is the actual project. The YouTube channel is here. This is all in Turkish. The guy's a Turkish guy, but I'm sure I can figure out from this and from the information that was uploaded onto PCBWay. We have the firmware files and really the instructions we need to build this. So that's the little device. And I was thinking of putting that inside the same enclosure as the signal generator, and I think we have a quite nice little bit of test equipment. These are the PCBs for the frequency meter, so these have arrived. It's quite a small one. It should fit nicely inside the same cabinet as this, hopefully with just the one power supply for everything. I'm sure we can figure that one out. So this can go in here as well, and with a bit of luck we'll have a bit of space the other side for the FM modulator. So I'll order the parts for this, probably take a little while to arrive, and we can have a play with that one. And then we'll have a combined RF signal generator and RF frequency counter. For those of you not that interested in RF signal generators, I took the opportunity to order some more PCBs from PCBWay, and I'm going to look at making some electronic load projects. We have a few different ones in mind. These PCBs are for a USB load tester, basically, so you can load USB port and make sure it's delivering as much current as it should do. We have this one. This is a simple electronic load. So this is a small electronic load with an OLED display, so we can have a little play with that and see what we can do with it. It's called the Tiny 85. It doesn't take very high loads, but I'm sure we can find something to do with it, which is interesting. But I also ordered some more PCBs. So again, these are for electronic loads. I have two different ones. The electronic load, one of these will take up to 300 watts. The other one I think was about 150 watts. So let's do a video comparing electronic loads. Let's put some of these things together and see how useful they are. I would like to build a effectively 3-channel electronic load that will be capable of, for example, loading an ATX power supply, so we can load the 3.3, the 5 and the 12 volts. We can set varying currents on the different outputs and run them under load. So I have those. And the last thing in this little batch is this one. This is something else I don't have. I thought it would be interesting to build. So this is a flyback testing. These are for testing switch mode power supply transformers and similar things that were used in the old days for CRT TV flyback testers. So I have this one as well. This is basically a little tester for transformers to make sure we don't have any shorted turns. It works up by just lighting up a number of LEDs. I know there's some very similar projects to this out there, so I decided to grab some of the circuit boards for this. These are quite simple. So it has LM393, which is a very common op amp, 4015M, which I think is a counter or something similar, CMOS chip, and the rest of it is basically resistors, capacitors. You know, this is the sort of thing that wouldn't cost much money to put together. So I'm very interested in this one. I'll order all the parts for these later this month, so I guess in October we can start putting some of these projects together. I'd just like to thank PCBWay again for the opportunity to build and review some of these projects, hopefully to improve them, and then we can submit our own PCBs for design. That's what it's all about, really. Yeah, this is an interactive thing, guys. So, you know, make your comments, get in there, see can we do any even more interesting stuff with these things that we have, the PCBs. I have now, I think, enough to keep us getting projects for a little while. I still have the milliometer to finish. We know it's working. I've sorted out a good idea for a plus and minus power supply for that, which I'm going to show you soon. Actually, this is just an idea of my own, and then we can do a head-to-head with that one and the short circuit tracer to see which is the best. Yeah, although I'm sure they both have their uses. Okay, guys, thanks for watching. I hope you enjoyed that one. If you have any other ideas for projects, just let me know and we'll see what we can do. and I will see you all soon on another Learning Electronics Repair video. Ciao for now, guys.